to the YouTube channel of Coding Club RVCE. Today we will be looking at the second problem for the CodeChef contest starters on 21 division 4. So let's look into the problem statement first. So we are given n, which denotes the number of urinals, and then we have to return two integers. The first one being the maximum number of people, and the second one being the minimum number of people, which can be using these urinals simultaneously such that they don't violate the condition that two urinals are adjacent. So it's not allowed for two people to be using the adjacent urinals. So this is the condition. And we have to return the maximum and minimum number of people. So let's look into some test cases. Let's take 3. So when we are taking 3, we can add one person here for the maximum case, and no person can be added over here, and the other person, next person can be added here. So 2 will be the maximum number of people. By dealing with the minimum case, we can add 1 in the middle, so that neither person can use this, neither this one. So 1 will be the minimum case. For the 5 number of urinals, we can start off with the same fashion over here. Give a person this one, don't give this one to any person. Give a person this one, don't give this one to any person because it will be adjacent word. So another person can be added here. So 3 will be the maximum. In case of the minimum also, we can start off with the similar fashion. Over here. Then here we can either go with 1 here, and here we can go with this one. Let's look into some other cases to find out which one will be the minimum one. So let's take 6. For the maximum number of cases, it will be 3 because we just add one more urinal over here and no person will have access because first it will be adjacent to this one. So let's consider the minimum one over here. So when we are going with the minimum one, let's consider the first top approach first. So this will give us the minimum as 3. Whereas if we consider the below one, it should be this will give us the result as 2. So this one is better. It gives a minimum 1. So let's consider another approach of 7. So in case of 7, the maximum one will be nothing but adding of another 1 over here. In the case of the minimum one, we can start off with the same fashion. Let's here this one, and then we can use this approach, and then over here we have to add 1. So 3 will be the minimum in the case of 7 as well. While we are dealing with 8, it will be the same 3 because no person can be given this one. However, when we change it to 9 over here, no person will be using this one. Just we will get 1 person, no person this one, no person this one. This is for the case of 9 minimum. So then no person this one. Then previously we had considered a person here and no person here. If we consider like that, we will get the 4 because a person here, no person here, then a person here. So 2 plus 2, 4 we will get. Instead of that, if we add 1 over here, we will not be not needing to add 2 people here. So this will give us the result as 3, the minimum. So what we can conclude from these observations is the maximum one is easy. It's just n by 2 seal. So we can write it as n plus 2 minus 1 by 2. So it will be n plus 1 by 2. For the case of the minimum, we can see that for the first, for 1, 2, and 3, it will be 3. For 4, 5, and 6, it will be 2. Because it's nothing but, for example, if I take the case of 4, it will be this case, the minimum. And 5 and 6 are nothing but we are just changing the position of this one. For example, if I consider 5 over here now, or 5 was, yeah, I'm just changing the position of this one while dealing with uh, for 5, I don't change the position of this one. Or it can be changed as well, or like this one. So I'm just changing it to the next position and this one won't be accessible. In the case of 6, it is just an X mark over there. So this is nothing but just changing the position of this one. So it will remain 2 for this. For these one, for the first 2 ones, it is 1. And then for the next keys, it is 3 for 7, 8, and 9, as you can see over here. So what we can infer is that it's just, this is nothing but related to the formula n plus 2 by 3. It's this is nothing but it gives us the uh, n by n plus 2 just gives us like basically it's nothing but the seal of n by 3, right? So when it is the seal of n by 3, what we can do is it's n plus 3 minus 1 by 3. So this is equal to n plus 2 by 3. So this is the simple logic. So in the code, they have given the sample input as 2, 3, 5 with 2 denotes done above test cases. So we start off with the variable p, then accept it, then run this for t test cases. The first computation gives us the maximum number of people which can use it without violating the condition. And this one gives us the minimum number of people which will be using it without violating the condition. Let's run and check this. So it was successful against the test case. Yeah, so it got accepted. Thank you.
Coding Club.